wait, I forgot to record. Okay. So today we have an expert from BAEC, Bangladesh Atomic Energy Commission, Dr. Mortuza. Assalamualaikum, Dr. Mortuza.
Walaikum assalam wa
Okay.
rahmatullah.
So is it clear to hear my voice?
Yes, yes,
Yes.
I can
Okay. So
hear you.
how are you, Dr. Mortuza?
Yeah, I'm fine. Thank you. And how are
Okay.
you?
Yeah, I'm good. Uh, Now I will introduce Dr. Mortuza first. Okay, let me share the screen. Okay, so this is the Dr. Uh, MD Muhammad, right? Okay, Dr. Muhammad Firoz Mortuza. He is from the IEC, especially from Gamma Source Division, Institute of Food and Radiation Biology, Atomic Energy Research Establishment, or AERE, from Dhaka, Bangladesh. And this is the educational qualification. He was completed, successfully completed his doctor in Tokyo University of Agriculture and Technology 2 years ago, and he also completed his master and bachelor degree from the same university, from University of Dhaka. Now he is a principal scientific officer in Bangladesh Atomic Energy Commission from 2022 to present, and his skill is molecular biology, microbiology, dosimetry, biotechnology, genetics, biodiversity, statistical data analysis, radiation biology, bioinformatics, and nuclear safety. It's a very wide skill and expertise. And this is for the recent project and publication. Of course, there are a lot of project and publication, but I have to select the recent one. And the recent project is an International Atomic Energy Agency coordinated research project as sorry, as a chief scientific investigator from IAEA research contract, and this is the recent publication. In this year, there is one publication from MDPI. I think this is the open access genetic and physiological characterization of soybean nodule derived isolates from Bangladeshi soils revealed a diverse array of bacteria with potential bread rhizobia for biofertilizer. So you can access this from the MDPI publisher. I think this is open source, so you can download free. So I think that's all for the sorry, I have to move this. Okay. That's the introduction to Dr. Firoz Mortuza. And now I will state the outline for this lecture. First, the presentation by Dr. Firoz, and then we will continue with discussion. In discussion section, you can raise your hand, or you can ask the question using a chat room in this Zoom meeting. And then last is the closing. And for the student, after the discussion section, uh, we will have a post test. So don't leave the lecture after the discussion, because there's still one step for student. And for uh, participant who are not a student, you can fill the attendance list after the discussion section. So now we can start the lecture. Dr. Firoz. Are you ready to start the lecture?
Okay.
Okay, so the time is yours. You can start the lecture. Thank you.
Can you share my? Can you see my screen?
Yes, yes, very clear.
Assalamu alaikum wa rahmatullah.
Waalaikumsalam.
Welcome to my presentation. The topic of my presentation is biological effect of radiation and application of cobalt-60 gamma irradiator. I'm Dr. Mohammed Firoz Mortuza, working as a principal scientific officer at Gamma Source Division, Institute of Food and Radiation Biology, Bangladesh Atomic Energy Commission. So, contents of my presentation. First of all, I'll talk about objectives, then basic information of radiation, then mode of action of radiation and biological effects. Then I'll talk about applications of gamma irradiator and activities of Gamma Source Division, my division. Objective. First of all, I would start with the quote of Marie Curie. She stated that nothing in life is to be feared. It is only to be understood. Now is the time to understand more so that we may fear less. And this is because we have in many cases a phobia about radiation. Whenever we hear about radiation, we become afraid. Uh, so first of all, we need to understand radiation so that we can understand that when we should be afraid uh, and when we should be careful and when we should not be frightened. So this thing, I'll try to explain a little bit about how radiation works and how much radiation actually we get every day from the environment and other things, and what is the usage of radiation. So the objectives are to provide useful information about radiation, to improve understanding of radiation, what it is, and how it interacts, to share and discuss about the effects of ionizing radiation, especially gamma radiation, and to inform about the applications of cobalt-60 gamma irradiator. Now, basic information of radiation. Okay. We are surrounded by radiation, actually. Radiation is a form of energy. There are different types of radiation, like visible radiation we commonly see in our life from sun, and there are other radiation. Radiation is of two types based on the ability to cause ionization. So some is ionizing, and some are ionizing, and some are non-ionizing. These are non-ionizing radiations like the infrared, microwaves, radio frequencies. We use these in telephones, in radios, in microwaves. These are non-ionizing. That means it doesn't produce any ion when it passes through a material or element like this. It doesn't cause ionization. On the other hand, there are high energy, high energy radiations like X-rays and gamma rays. So these things, they can produce ions, and whenever they interact, So they causes ionization in the materials. So these are actually a matter of concern mostly. And there are also radiation can be categorized as particle type and wave type. For particle type, alpha particle, beta particle, neutron beams, proton beams. These are the particle type. So alpha particle, as we know, it's a helium nucleus, nuclei injected from a nucleus. Beta particle, it's like electron ejected from a nucleus. A neutron produced in nuclear reactors, accelerators, etc. Proton beams also produced in accelerators. So these are particle type, and there are also electromagnetic waves, and they are in the form of wave, like X-rays and gamma rays. So X-ray and gamma ray both are photons. X-ray are generated when electrons within an atom are caused to travel between orbits by incident electrons are called characteristics X-ray. That means X-ray and gamma ray, the difference is from the origin. Gamma rays are produced in the nucleus and X-rays are produced in the electron shell. But both of them are designated as suppose energy is MeV. MeV. So both of them are photons. Uh, Here I will focus on some properties of different ionizing radiation, especially alpha, beta, and gamma. So alpha is +2 charge. As I said, it is helium nucleus +2 charge. Yes, it can pass 5 to 7 centimeter in the air, and it will get neutralized because it is highly charged. So electron will interact and it will become neutralized. Uh, Big problems occur when we eat something or inhale something that contains alpha. In case of beta, beta has minus charge, -1 charge. It can travel up to 4 meters in the air, depending on the MEV, I mean the energy of the beta. If the energy is high, then it can go more. Uh, but basically, normally for one MEV, it's about 4 meters. The health risk is superficial skin injury. And for gamma and X-ray, it doesn't, they don't have any charge, so it can travel lots, big distances if they are not interacted. So up to 500 meters if they are not interacted. So, so the health risk is whole body injury at high dose. So if we have gamma irradiation at high dose, then it will pose some health risk in our body. So this is another picture to understand. So alpha, it will interact with the skin. It cannot usually pass the skin, so the organs will not be affected if it is from outside. But if we eat or if we inhale, then it will go directly in our inside our body. So then it will cause problem. From outside, alpha and beta cannot, alpha cannot enter the organs. In case of beta, it can penetrate the skin and it can interact in the tissue. And gamma, it can penetrate the skin tissue bones, or so it has high penetration. There are different type of shielding material that we used for to stop these radiations. Like for alpha, the ionization is very high. You can see there is three symbols of radiation. Ionization is very high. but it can be stopped with a simple paper. Whereas beta, it can be stopped with a thin aluminium, and gamma and X-ray can be stopped with thick lead. You need very thick lead to stop gamma and X-rays. And for neutrons, it can be stopped by water and concrete more efficiently uh, by water. Now, units of radiation measurements. Radiation measurements are uh, measured with different units. For radioactivity, it is measured by becquerel. The SI unit is becquerel. So 1 becquerel equals to 1 disintegration per second. 1 disintegration per second. To understand that, suppose there are many atoms, 1000 atoms, and if one of them disintegrates in 1 second, so the radioactivity of that amount of atoms will be 1 becquerel. 1 becquerel. And absorbed dose is measured in gray. Gray is 1 joule. 1 gray equals to 1 joule per kg. And that means, suppose the radiation that is coming, if a material absorbs 1 joule, and the weight of the material is 1 kg, so it means that the absorbed dose is 1 gray. And there are also other measurements like equivalent dose and effective dose. These are measured in sievert. So I will explain it in the next. So understand again that suppose this is a radioactive material, and the radiation intensity is measured in becquerel, um, and receiving side, one person is receiving the radiation. So it is calculated in absorbed dose. Absorbed dose. So amount of energy absorbed by a substance of unit mass that received radiation. So there are many equipments or dosimeters, we say, by which we can uh, calculate the absorbed dose. So by the absorbed dose, and if we divide it with the weight, then we get the gray, how much gray uh, one person or one thing is getting, how much absorbed dose is getting. Now, there is another parameter. As you know, there are different types of radiation. So, difference in effects depending on types of radiation. There is different differences the effect due to types of radiation. Now, to calculate equivalent dose, we have to consider these differences. And also in our body, there are different organs. So some organs are more sensitive, some are less sensitive. So to understand the effective dose, we take into consideration that tissue weighting factor. So this I will explain more. Suppose equivalent dose, as I said, and that it depends on types of radiation. For gamma, X-ray, beta particle, the radiation weighting factor is 1. So that means 1 gray into radiation weighting factor 1 is 1 sievert. 1 gray equals to 1 sievert for gamma ray, X and beta ray. But for suppose alpha particle, the radiation weighting factor is 20. So when we measure that 1 gray dose has been absorbed, and we multiply it with 20, so the equivalent dose is 20 sievert. 20 sievert. So this is high in the equivalent dose. And effective dose. So effective dose is calculated by the summation of tissue weighting factor into equivalent dose. Now we get this equivalent dose, and afterwards we multiply it with the tissue weighting factor. This tissue weighting factor is high for red bone marrow, colon, lungs, stomach, breast, etc. And it's low for like neurons and this thing, the brain. So, so, so the red bone marrow, it will be more affected by radiation in suppose the salivary gland or the skin. The tissue sensitivity, if the active cell division is high, more cell division, then the sensitivity is also high, radiation sensitivity. So hematopoietic stem cells like the bone marrow and lymphatic system, they are very sensitive to radiation. On the other hand, like transmission system, nerve system, because they have almost no cell division, or suppose very little cell division for these, uh, so they have low sensitivity to radiation. Now, where is radiation? We think that radiation is only in the uh, in the radioactive sources that is used in industry or in the nuclear power plant. Actually, it is not the case. Radiation is inside our body. There are many different types of radionuclides we have in our body. There are many uraniums and thoriums and poloniums, but we have mostly potassium 40, potassium 40 and carbon 7 inside our carbon 14 inside our body. So, so we contain about 140 gram potassium. A person who is about 70 kg of weight, he has 140 gram of potassium inside his body. And according to the natural abundance, so about 12, 12 potassium 40 is present in 100,000 potassium. So in case of, suppose there is 100,000 potassium is there, so there will be about 12 potassium 40. So this potassium 40 radioactive. So inside our body, and there is um, mm, there is about 4,000 4,375 becquerel radiation that we get from this potassium, because it disintegrates this potassium, radioactive potassium, it disintegrates. So uh, each second, inside our body, we get 4,375 disintegrations due to potassium 40. So we have radiation inside our body. Okay? So radiation dose per year from potassium 40 is about 1.3 into 10 to the power minus 4 gray. 1.3 into 10 to the power minus 4 gray. And this much of radiation we get from potassium 40. And also from the environment, there are many other things, radioactive things that contributes the annual dose that we receive from radiation, like cosmic rays. Cosmic rays gives 0.28 millisievert of radiation, and cosmogenic radionuclides. Cosmogenic radionuclides are those that are formed in the environment due to interaction with cosmic ray. So we have these radionuclides, cosmogenic radiation, and internal radionuclides that I already described, potassium 40 and others. We get 0.26 also, and inhaled radionuclides like radon. Radon is produced from uranium from our soil, and also we get it from the walls that we use cement and this thing, concrete. So we get radon from the aerosol. So we inhaled 1 millisievert of radiation of the air. A human being absorbs about 3 millisievert dose per year from nature. 3 millisievert. Now, let's talk about the mode of action of radiation. So, so now these are suppose X-rays and gamma rays. What they do, they have direct action. And there are two types of action, direct and indirect action. So directly, what they do, they displaces or uh, electron, they hit electron and displaces it from the atom. So the atom become positively charged. Now this is the direct action, and afterwards the electron that is displaced, it has high energy, and this energy came from the X-ray and gamma ray. So these electron will interact with other things. Now inside our body or inside cells, uh, there is about 70% water. So the most interaction occurs with water. So these electron, it produces different type of free radical. Or simply, I will put it like this: that from this interaction, indirect action, and there will be many ions and free radicals. These free radicals will react with DNA, RNA, proteins, carbohydrates, whatever it gets nearby. Now we basically mostly we are concerned about DNA because we know that we have a single copy of 23 pairs of chromosome, but we have many proteins and RNAs and other things which can be produced from DNA. So that's why scientists are more concerned about the effect on DNA. Now, because short life of simple free radicals, and these radicals are very short life, 10 to the minus 10 seconds. They are very reactive. Only those formed in water column of 2 to 3 nanometer around DNA are able to participate in indirect effect. So suppose there was water here and the gamma ray produced these radicals, so it will react with the DNA and it will make different types of lesions or damages. Uh, Now, what type of DNA lesions or damages it produces? Basically, uh, this is an estimation of numbers of DNA lesions after 1 gray dose of gamma radiation. 1 gray dose is very high, very high. There is no way we can get it. We can get it from our environment unless there is any accident, nuclear accident, or like this. So this is estimation. If 1 gray radiation a cell absorbs, so these are the damages that occurs. Now, this 1 gray radiation is also for one time. Is one time, I mean, in 1 minute or in very short time, if a cell get this radiation. And previously, in previous slide, when I talked, when I showed that 3 millisievert dose we get from the environment, it is in the whole year, for the whole year. So we should think about it. Uh, so 1 gray dose will cause this kind of problem. Okay, there will be base damage, 1,000 to 2,000 like this, and deoxyribose damage about 1,200. Most and the big problems occurs for the single strand breaks and the double strand breaks. And this is most lethal, the double strand breaks. I mean, both the strand are uh, broken down. So it is difficult to repair. So it makes many problems. Okay. So double strand break for 1 gray about 40, 20 to 40 actually. 20 to 40. So what the cell do? Okay? Cell has many complex signal transductions, as I can and repair pathways to respond to DNA damage. Like suppose cells have been irradiated. Now there is damage, chemical or radiation, chemical changes. Okay. Now repair enzyme will work there. So if the and there is incomplete repair, if the repair mechanism doesn't work properly, so there is mutation. There is mutation, possibility of causing cancer and hereditary effects. And if uh, uh, repair failed, I mean there is many double strand breaks. In that case, repair failed, so there will be cell death or cell degeneration, and it will cause possibility of causing acute effects and fatal effects. And if repair succeed, so there will be no hazard. Now there is another thing, another picture to make understand. So normal cells, if very low amount of radiation, few cell damage, and one dead cell maybe, and suppose and other cells are repaired, so no effect. And in case of the moderate amount of radiation, suppose many cell death, temporary dysfunction, and recover, even this will recover afterwards. If there are high doses, in that case, there will be many cell death, so loss of function and morphological defect. Fortunately, in human body, there is an antioxidant process to neutralize free radical and very efficient DNA repair system to repair DNA damage. Now, this figure, the, this paper was published in Nucleic Acid Research 2009, which is a very good article. And this, the scientists showed that I will explain this, that these are pre-irradiated cells, the human cells, pre-irradiated. And these are like yellow fluorescent protein 53 with binding protein 1. They tagged yellow fluorescent protein. So basically, I will say that these are indicators. These are indicators to indicate double strand break. We call it foci. So number of foci represents a number of double strand break. So suppose for 100 milligray dose, there will be about 2 to 3 double strand break. For 500, about 10. And for 1000 milligray, that means 1 gray, there will be 20 to a little bit more than this double strand break. This is the graph showing that it increases with radiation. Now, repair system. How here you can see that, and that with time, the cell repairs the double strand break. And like suppose in 4 hours, this is 10 milligray dose, 50, 100, 500, 1000. So in 4 hours, and there is none. There is maybe one. There are few foci, that means double strand breaks, and there are also many foci which decrease than previous. Okay. So by this graph, we can say that with time, the double strand break repair, the cell repairs the double strand break, and in 8 hours, almost in case of 5, 10, and 50 and gray, there will be no double strand break, and the body will repair. And for a little bit high doses, it will take a little bit more time to neutralize. Now, what causes cancer? We think that from radiation, there is mutation and it causes cancer. This is the only source. Actually, If you see that, as I showed in previous slide, that gamma radiation, one gray gamma radiation, causes this kind of problem, base damage, single stand break, double stand break, and this kind of problem. But we should know that in our body we have cellular metabolism system for to produce, suppose, energy and do other stuffs. So cellular metabolism, it is continuously happening or performing in our body. Now, due to cellular metabolism, every day, in every cell, there is 12,000 base damage. There are more than 55,000 single strand breaks, and there are 25 double strand breaks that occurs inside our body, inside our cells every day. 2 to 3% of all metabolized oxygen is converted to free radicals during cellular metabolism. About 70,000 lesion is produced per cell per day due to cellular metabolism. This results in an average of about one mutation per cell per day. However, background radiation that we talk, that we have radiation from environment, from our body like this, background radiation produces uh, 10 to the power minus 7 mutations per cell per day. So much, much lower than cellular metabolism. Now, I'll try to talk about the applications of radiation. Now, gamma irradiators are equipped with high activity radioactive sources of cobalt 60 or cesium-137, which are used for different purposes such as sterilization or decontamination, etc. There are many applications of gamma radiation, like medical equipments, pharmaceutical products, tissue-based biological products, radiotherapy in oncology, cosmetics, and toiletries, research and development, food irradiation. We can see that it has many, many different types of uses. So even for cancer therapy, we use radiation of high dose. And there are also other uses in all sectors actually. For in food irradiation is a technology which applies ionizing radiation to food or improving the safety of food and extending the shelf life of foods by reducing or eliminating microorganisms and insects. Food irradiation is a very safe process and is permitted in over 60 countries, and about more than 500,000 metric tons of food are processed annually worldwide. So, in case of food irradiation, there are different types of sources that are used. As gamma rays are used, like cobalt 60 and cesium 137. X-rays are X-ray. There are many powerful X-ray machines that are used for food irradiation also. As I said, that gamma ray and X-ray are similar in their actions, only they differ in the origin. Uh, and electron beams are used also. Electron beams, and they are high energy electron beams which can irradiate in very short time large amount of product. So in many countries they use electron beam to sterilize products and also for food. Irradiation can serve many purposes like prevention of foodborne illness to effectively eliminate organisms that can cause foodborne illness, and it can use for preservation and to destroy or inactivate uh, to destroy and inactivate uh, organism that cause spoilage and decomposition and extend the shelf life of food. It can be used for control of insects, to destroy insects, and also for delay of sprouting and ripening, like for potatoes. And it is also used in sterilization. Irradiation can be used to sterilize food. There are also suppose many the AIDS patient who cannot eat normal food. In those cases, sterilized food is used. Purposes. There are different purposes for which radiation can be used. Depending on the dose, it can be categorized in three categories. One for low dose, medium dose, and high dose. Low dose is up to 1 kilogram. It is called radiosedation. And medium dose is 1 to 10 kilogram. It is called radiorization. And high dose above 10 kilogram. It is called fat apartization. So, using low dose can inhibit sprouting, delay in ripening, prevent insect infestation, and parasite control and inactivation. These for these things we use low doses. And to extend shelf life of raw and fresh fish, seafood, and fresh produce like different fruits, and extend shelf life of refrigerated or and frozen meat products, reduce risk of pathogenic and spoilage microbes, and increase juice yield, reduction in cooking time of dried vegetables. In these cases, we use medium dose, 1 to 7 or 10 kilogram. For high doses, like uh, to dehydrate, uh, in case of dehydrated enzymes, for sterilization of spices, dry vegetable seasonings, and sterilization of packaging material, sterilization of food for astronauts or hospital, the high dose of radiation. Now I will briefly describe about the activities and information of gamma source division where I work. So we have a cobalt-60 gamma irradiator. We know that cobalt-60 is produced from cobalt-59. Cobalt-59, when it is irradiated with neutron, then it makes cobalt-60. So this cobalt-60 is radioactive. It neutralizes, become nickel, and in that pathway, it disintegrates. It emits one beta and two gamma rays. The gamma rays are very high energy gamma rays, 1.17 mega electron volt and 1.33 mega electron volt. So these gamma rays are used in different purposes in our division. Initially, a cobalt-60 gamma source was brought from Canada in 1980s, and afterwards, in 2000, a 50 kSA cobalt-60 backside gamma irradiator was installed by BRIT India. In 2014, the activity was increased to 90 kCi in cooperation with BRIT India. At present, the source activity is about 30 kCi. So this is the source. It is inside the soil, inside the earth, and this is the control panel. We ping it up when we need to irradiate sample. Now we give services to research, R&D purposes and commercial purposes. For R&D purposes, we give it at free of cost, and for commercial purposes, we earn revenue from this. So organizations from all over the country in Bangladesh come to our division for their irradiation purpose in R&D. So Institute of my organization, BAC, and also other research organizations come to take the irradiation service. And also for commercial service, both food industries and medical and pharmaceutical companies come to our facility to take irradiation service for different purposes. R&D services, Gamma Source Division provide irradiation service for research to different private and government organizations, including institutes of BASF or free of cost. And these are some of the list of organizations, and these are the name of products and those applied. Like for food. There are dried fish, fresh fish, bitter gourd, pineapple, and spirulina, and many different types of research samples are irradiated. And these are other organizations other than BAC. They also send their product to us for irradiation, like rice seed, peanut, and also recently they irradiate peat soils like this, and other products also irradiate. For commercial services, spices, raw materials, pharmaceutical raw materials, surgical materials, and injections and syringes are also irradiated here. Spirulina, turmeric, mushroom, bull sticks, goat hair. These are for pet food that are irradiated here and exported to other countries. Gamma-Source division provide irradiation service to commercial products of different medical and pharmaceutical companies and food processing and manufacturing companies of Bangladesh and earns revenue for Bangladesh. These are some of the lists of different organizations and their product and dose applied. Mostly the doses are high because they used for sterilization, about 25 milliliters. These are also some other name of companies in their product. So now I'll give a very short video to just for the conclusion. I hope please listen and watch the video. So, so basically, there are many uses of radiation, but as I said, that we need to know, we need to learn, we have to be careful, but we should not be afraid. So there are three basic rules for external radiation protection, and that is time, distance, and shielding. We should be in a radioactive place for very short time, and we should try to maintain distance from any source if we know, and we should try to use shielding so that we can protect ourselves from radiation. So the issue of radiation exposure is not a matter of safety only, it is also a matter of benefit compared to risk. We need to be cautious and careful about radiation, but we should not be frightened unnecessarily. Thank you very much. In Bangla, we say আপনাকে অনেক ধন্যবাদ, and in Indonesian, terima kasih banyak. Thank you.
Okay, thank you very much, Dr. Firoz, for the brief lecture about the radiation. Okay, now we can continue to the second section about the discussion. Okay, for student or maybe for the all participant, you can uh, raise your hand or you can write your question in the chat box. Okay, so you can ask directly to Dr. Mortuza, Dr. Firoz, or you can write your question in the chat box. So, Dr. Firoz, about the application of this radiation, actually, honestly, I never see the equipment for radiation because I think it's special equipment. So if the industry or if the farmer want to apply the radiation to extend the shelf life of the product, so what should they do? They should send their product to the for instance to the BAEC, or the BAEC has the like a portable device to uh, apply the radiation to the product directly in the farm, or how is the practical of the application of this radiation?
Okay, thank you very much for your question. Actually, radioactive sources and there is safety and security issues are there. So it cannot be it cannot be mobile actually because there are a strong infrastructure that needs to be in place, because when we irradiate something, we take up the source in the product level, then the radiation is very high. Therefore, in our facility, suppose there is a shielding of high info concrete stone chip shielding of suppose 5 feet, uh, 5 feet thick shielding is there in our facility to protect the environment. So it cannot be mobile. There is some e-beams that e-beam has the capacity to switch on and off. And in Korea, we saw that they have a mobile e-beam system to irradiate industrial effluents. So they have that special kind of facility. But in most of the cases, if you want to use gamma ray, X-ray, or e-beam, this thing for irradiation, the facility has to have some special infrastructure. Therefore, the food or other products, it needs to be sent to that facility. And the irradiators, it is actually not possible uh, or very difficult to take it to the place of the product. And also, suppose because radioactive material, in case of radioactive material, have to be very careful about the security of the source, so that there is no theft or no sabotage. Otherwise, it will be a big problem for a country. And therefore, a special uh, infrastructure and a special physical protection system and other things need to maintain to use this kind of facility.
Okay, thank you. Now we have one student raise hand. Okay, Ola Rizka, please you can ask directly to the the speaker.
Okay, my name is Olariska, and I would like to ask about in the pretest there is question about radiation can control of insect. So I'm curious, and please explain about how can radiation control of insect in irradiate food. Thank you.
Okay,
Okay.
thank you. So,
Thank you very much for your question. Uh, Radiation, suppose in food, we know in fruits and vegetables and rice and or uh, there are many insects that can grow inside. There are like fruit borers, different type of lepidopteran insect and other things. Uh, by giving radiation, we kill the insect. This is especially needed when food products are exported to other countries, uh, mm, and also when we import from other countries. So the radiation is in many cases recommended to kill the eggs, larvae, or pupae inside the fruits, so that we can control the emergence of new pest from other country to a new country. By radiation, uh, when by radiation we can kill those insect. Usually, uh, manufacturer they send their different kind of products. Like in our case, we irradiate spices in huge amount. So they send their products in boxes, and we irradiate at a different dose to kill what is inside. At the at suppose we give them 6 kg or 10 kg, at that dose, all the killed. Because usually for insect phytosanitary purpose, only 400 gray dose is needed. So 400 or 500 gray. So if we apply 6 kg, undoubtedly insect will be killed. Is it okay?
okay, how about the answers, Ola Rizka? So basically, the key point is the dose of the radiation, right? So if how much the radiation we need to kill the larvae or the pulpit and other purpose, is that right?
Yes. The dose is the most important thing. And another thing I want to say, I want to inform that radiation is something that will not make the food or the other product radioactive. In simple way, suppose we enlighten by light, but if the light is switched off, then there is no light that comes from our body or from other things like this. So, if we irradiate food, if we irradiate something with gamma radiation, cobalt 60 gamma radiation, it will not become radioactive. There will be no radiation that will come from that thing afterwards. Even suppose if we put a product for 100 years in a cobalt 60 gamma irradiator, that product will not become radioactive. So if we see sometime that it has been irradiated, sometime we become afraid that, oh, irradiated food. But actually there is nothing to be afraid of, because that food is not radioactive. It has the positive thing is that there is less or no microorganisms that can harm our body. Uh, so uh, So we should know that irradiated food is scientifically proved that it is safe to eat and use. Yes.
Okay. Thank you, Dr. Mortuza. And we have another question from a student. Actually, maybe you already explained the answer, but maybe I will read the question first. I'm Ragilia, a Jember University student in 2021. Permission to ask about application of gamma irradiator. I understand that a food must receive the minimum radiation dose necessary to achieve the desired effect, and that a uniform ratio must also be maintained at an appropriate level. I want to ask about the irradiation dose or for meat. Is it the same for all types of meat? If the measure reduction in the meat exceeds a predetermined limit, what will happen to the meat? And what happen if the meat is consumed by a human?
Okay. First of all, that is it the same for all types of meat? Actually, almost same, almost same. But depending on the purpose, or depending when we know that we have different type of contamination in a meat, then we need to treat it differently. Otherwise, there is a IAEA standard for meat, and that how much radiation is necessary, and all the regulatory bodies, or every country has their setup for doses for irradiating different type of products. So for meat, it is almost fixed, unless there is any special circumstances, a special issue, the radiation dose is same. Now, the second is, if the major radiation in the meat, radiation in the meat exceeds a predetermined limit, what will happen to the meat? Now, usually, suppose the meat is to be radiated at, suppose, 1 kg dose. Now, if it exceeds to 2 kg, that will not create big problem. Actually, no problem. No problem. That will not create. And the thing is that usually when we cook, there is many different types of chemical changes that occur when we cook. Now, as I showed, that radiation produces free radicals, which causes different types of breakdowns and chemical changes that has many similarities with the same thing that we do in cooking, or in enzymatic breakdown like this. So if the dose exceeds, and if it is little bit more, it will not cause any significant problem the meat. But that uh, check we have to check case by case. I mean, not not a formula will not always work. In different cases, we have to check whether it's okay or not. Sometimes we want to kill the bacteria by radiation, but it can cause odor. Now, if a food has bad smell, so no one will try to take it, and the company can't sell it. So we have there is many things that have to take into consideration: the purpose, and for what we are using radiation, and the effect of radiation, and what will happen afterwards. So this thinking all these things, if the process is validated, afterwards the manufacturer, the company comes for radiation, and we provide radiation. Or this is the system all over the world, like this. So the process must be validated first, whether it's okay or not. Afterwards, it's given radiation. And the last, what happens if the meat is consumed by humans? Yeah, as I said, that there will be no bad effect, because radioactive food, radiation given food, irradiated food is safe to consume. But I should again remind you that if it is radioactive, uh, suppose someone grow food or rice in Fukushima, where in 2000, after 2011 there was high radiation. Now that food have radioactivity, high radioactivity, and so that food is radioactive food. So radioactive food, it is not good to eat radioactive food, but irradiated food is safe because it doesn't have any radiation. Is it okay?
Okay, how about the answer, Miss Ragilia? Yes, we know the accident in Fukushima 2011, and some uh, fish also became radiation. I don't know,
Radioactive. Yeah. I-
radioactive fish. So
Mhm.
radioactive and irradiation is different. So
Yeah, radioactive
yeah,
means if some the fish, suppose they ingest, they eat, okay, in simply, they eat the radionuclide that was in the water due to the explosion. So it got inside the fish. So they become radioactive, highly radioactive. Usually, everything has radiation. As I said, in our body also we have radiation. So, but this is normal. Now, if I eat some radioactive things, then I become exceedingly radioactive, the normal cases. So that fish become radioactive uh, due to the problem.
okay. Thank you for the answer, Dr. Firoz. Okay, uh, another answer, and sorry, another question from student. Just for okay, just for information, the pre-test and post-test question is made by Dr. Firoz. So I just arrange to the Google form and I send to student. And after the student fill the answer for post-test, I will make a summary and I will send to Dr. Firoz to for maybe you need some information about the result of the uh, question that you already made. Okay, now we have another question from Semesta Tulang Cahaya. One of the student in the sorry, I want to ask about your opinion, Mr. Firoz. From the many method of manipulating radiation, which one is the most effective to apply and can be an effective alternative method in terms of its use or technological readiness in agro industry? So do you get the point of the question?
Yeah, I will see the question. Uh, okay, so how can I see? Can you please again read the question?
Okay,
See.
the question from the many methods of
Uh-huh,
manipulating radiation,
uh-huh.
which one is the most effective to apply
And can
and
be
can be an
an
effective
effective
alternative method in
alternative.
terms
Okay.
of its use or technological readiness in agro industry?
Okay. Now, manipulating radiation. Okay. Okay. This is uh, I will say that suppose there are many methods of radiation, like suppose the gamma rays, X rays, and E beams. E beams. uh, uh, E-beams in different type of radiation has different type of uses. Like in cobalt 60 gamma irradiator, the it is continuously decaying because it is a radioactive material. It is continuously decaying, and uh, uh, but it has good penetration, high penetration than E-beam. E-beam radiation. It is better in that sense if we want to irradiate something with higher thickness, I mean lots of product, then gamma radiation is better than E-beam. But suppose if we want to control like switching on and off, we cannot switch on and off a gamma irradiator. I mean, the irradiation process is always there. A cobalt 60 gamma source is always decaying, always decaying. So there is some uh, misuse uh, because we cannot use it all the time. But in case of E-beam or X-ray, we can switch it on and off depending on our need. So it is a good way for radiation uh, among these processes. Which one is the best, most effective to apply and can be effective alternative method?
Yes, maybe
Okay.
the application in agro industry, maybe which
Yeah,
one is more
yeah.
effective.
As I said that it will depend, uh, and all type of processes has both pros and cons. They have positive and negative side, and all these type of methods are applied also in agro industry nowadays. Um, so so it will depend on our use, how will we use it. Yes.
Okay, so it depend the purpose of the radiation process.
Yeah.
Okay, thank you for the answer, Dr. Mortuza. And maybe one more question from the student. You can raise your hand or you can write or type your question in chat column. No one? Uh, okay, we have another question from Zain. Permission to ask for it dosage as recommended. Various consideration is required in the supervision of irradiation procedure. Then what consideration do we need to for the dosage?
Various consideration is required in the supervision of radiation procedures. Then what considerations do I need? What considerations do I need? Mm.
Maybe the dosage for preventing sprouting is different from killing the bacteria. So what consideration that we need to make sure that the dosage is good enough, or it
Okay.
has already standard to for its product or for its purpose.
Yeah, maybe in one slide I showed. Uh, so, uh, Suppose for potato to inhibit sprouting, because if we try to store potato for a long time, so they become sprouted and we cannot use or store it for a long time. So for that case, less than 1 kilogram dose is recommended. If we give less than 1 kilogram dose, the proteins inside the potato and other things that make the sprouting, they will be broken down, so there will be no sprouting. Similarly, suppose if we want to sterile a product, I mean there will be no microorganisms, no bacteria, no fungi, nothing. So at that case, we have to irradiate it for higher dose, suppose 10 or 25 kilogray dose to kill all the bacteria. The one thing is I need to I want to mention that suppose there is the bigger the size of the creation. Okay, like I will simply say that suppose human beings is bigger than insect, the insect is bigger than fungi, fungi is bigger than bacteria is bigger than virus. Uh, so the bigger the organism, it needs lower dose to kill. So, a fungi, it insect will be killed in suppose 1 kilogram. A human will be killed in only 10 kilogram, 10 gray, sorry, 10 gray is enough to kill a human being. 10 to 20 is enough to kill a human being. Now, in gray level, for insect, it will take about 1 kilogram. Or from bacteria, it will take maybe 10 to even 25 kilogram. And for viruses, actually, it is almost difficult to kill virus, but it will take much more higher dose to kill a virus, much more higher. Now, that's why we need to understand the purpose, and that if we want to sterile a product, then we have to give high dose. If we want to decrease the bacterial contamination and kill fungi and this thing, then we have to give doses, suppose 5 kilogram dose. If we want to only extend the shelf life, we don't want to kill all the bacteria or this thing, then 1 kilogram or near about 1 kilogram dose is enough. For sprout inhibition, less than 1 kilogram dose is enough. So by this way, we have to consider the thing, our purpose, and we have to apply it accordingly. And there is already actually standards. If we search the net, we can get that how much should we apply the dose and this thing. And by our own study, we can also determine. Yes.
Okay, so the important thing is time and dose, right? To get the goal of the purpose, like killing bacteria or prevent sprouting of potato and others.
Yes, time and actually dose is the main thing. Time actually, usually in irradiation, we use it for one time. I mean, the product is irradiated in one time. And usually it is for short time, period of time, uh, depending on the activity of the irradiator. Like as I said, in our case, it was 90 kci. Now it has decayed and now it is 30 kci. So previously the product that was irradiated in 1 hour, now we need to irradiate it for 3 hours to give the same dose, because the activity decreased. Uh, so the most important thing is the dose delivered to the product. And usually in irradiators, they give it in one time. So this is the way.
Okay, thank you for the answer, Dr. Firoz. Another question. Maybe we have about 6 minutes left. Okay, you can raise your hand or write your question in the chat box. Okay, no one. Okay, I think the student already oh, we still have one, maybe they still need time to write the question. Okay, the question is, can the use of radioactive ionization make spoiled food clean again, or can it be recycled during preservation? Then the three common application of and those categories in ionizing radiation have side effects if over applied. Then how effective is the use of radioactive ionization in the food agro industry? So okay, there are three questions.
Okay.
Okay.
First of all, thank you for your question. Now, uh, can the use of radioactive ionization make a spoiled food clean again, or can it be recycled during preservation? No, actually, it cannot. It cannot. Uh, suppose it cannot make a spoiled food clean again, but it can kill the bacteria that is there still, and it can make it bacteria free. But no one will eat a spoiled food. Uh, but by radiation, it can kill the bacteria and what is inside um, other microorganisms. But it cannot, suppose it cannot give a good odor, good smell by radiation, but it cannot make it beautiful. It sometimes it changes color,
Mm.
like we sometimes put glass white and it become black. And so there will be change of color. Uh, but it cannot actually make the spoiled food clean again. Um, uh, Now, then the three common applications and those categories in ionizing radiation have side effects if over applied. Uh, the side effects if over applied. Over is of course because if you give radiation, it will it will have some effect. It will have the effect. Now, if you over applied, then it will suppose one if you give radiation for 1 kilogram, it changes the color little bit, and if you apply it more, then the color change will be more. Similarly, in case of research, there is we sometimes irradiate rubber and chitosan and many things. So they polymers they give radiation for cross-linking. Now, if we give radiation for certain amount of dose, then it has one effect, and if we over apply the dose, then there will be more cross-linking, or there will be less cross-linking. It can vary. So with radiation, it will change, obviously. The effect can be good or bad. It is not sure, but with radiation, it will change. Then how effective is the use of radioactive ionization? Radioactive ionization, the food industry. Yeah, as you can see that nowadays more than 60 countries using radiation, and almost all countries use this in also in case of agro industry. And in case of Bangladesh, the expectation or the demand is increasing day by day, increasing day by day. So obviously, the use of radiation in agro industry has many good effects, and Indonesia is also using radiation in many different purposes. Like previously it was Batan, now maybe Batan is inside Brin, so they have many activities, alhamdulillah, in all sectors. Yeah.
Okay. Thank you for the answers, Dr. Firoz. Uh, maybe the time is up, so maybe we will go to next session. The next session is for student actually. We will have a post test from your lecture. We will evaluate how is we if we compare with the pre-test that we already complete in the before the lecture. And Dr. Mortuza, thank you very much for your lecture. Of course, I will contact you after this, and we will talk about last year. Actually, I still remember that how if we make uh, like agreement just to make sure that our institution has collaboration for the next year or the next activity. So for the detail and others, I will contact you directly. Okay.
Okay.
Once again, thank you very much, Dr. Firoz Mortuza, for your lecture. Very detailed and a very good presentation. And thank you very much. You
Yeah,
can
thank you.
okay. You can
Yeah,
leave this, or you can still hear, because maybe I will give instruction to the student in Bahasa Indonesia and okay.
okay. Okay. First of all, thank you, San. Thank you very much. And I would like to thank all the students for listening to my lecture. And if there is anything you want to know further in which I can help, I have very limited knowledge actually, but still I will try my best to answer you. And so so if you want to contact, please don't hesitate, and please pray for me and for all of us, inshallah. Okay. We'll see
So
you in future, inshallah. Assalamu alaikum.
okay. Waalaikumsalam warahmatullahi wabarakatuh. Oke, baik untuk adik-adik mahasiswa ya. Tadi di awal sudah kita laksanakan pretest. Nah, setelah dapat lecture ya, dapat kuliah dari Dr. Firoz, kita akan masuk ke sesi post test. Bagi Bapak Ibu yang dari instansi lain ya, dari institusi lain, terima kasih atas kehadirannya. Bisa mengisi ini attendance list untuk yang non mahasiswa ya. Jadi nanti kita akan bisa dapat datanya. Terima kasih banyak untuk mahasiswa. Ini adalah link post testnya. Ya. Jadi silahkan, di situ ada link post test untuk diisi. Karena nanti soal dan jawaban itu dari Dr. Firoz. Jadi saya hanya membuat dalam bentuk Google Form saja. Ya. Jadi nanti penilaian dari beliau itu akan saya serahkan ke perkuliahan yang sudah diwajibkan itu ya, untuk dipertimbangkan atau untuk dimasukkan ke dalam porsi penilaiannya. Oke, baik. Postes masih saya buka ya sampai jam 1 kurang seperempat. Tetapi untuk kegiatan ini akan saya tutup